Alright, so before we get back to coding, we're going to go over the system. Right now, we're going to use this development board. It is an Arduino Mega 2560. What that means is this chip right here is an ATmega 2560. And it's very common. It's an AVR is the type of processor. It's an 8-bit processor. And you can get these things really cheap. Now, if you look right here what we have wired, on the board right here, we have these pins right here are all for power distribution. Right here we have VN, so if I was going to supply power to this board, not through these measures, I would put it in right here. And then we have ground, 5 volts, and then 3 volts. And we are using a ground, we're skipping a pin, and then we're using the 5.5 volts because we are powering this via USB right now. And then from this 5 volt output on this board, we are feeding the red line right here. This red line is our power rail, and likewise adjacent to it is the blue, which we are going to use our ground rail, which returns to our controller right here. So we have these. Now if we see everything else that's wired, it's just these three right here to our IR sensor. We have our signal, the orange is our power, 5 volts, and then our brown is our ground. And likewise, we have the wires that are feeding our servo, and we're using the same exact color scheme. Brown is ground, the red is 5 volts, and then over here this orange / yellow kind of colors thing is our signal line. And you'll notice right here we have this yellow one going to the IR sensor, and then this black wire we're just using this extension is plugged directly to this yellow one. Now, last thing we're going to do is when this rotates, we're going to make a very, very simple, very cheap ultrasonic imaging system. And what we're going to do is we're going to take this. This is an HC-SR04. This is a really inexpensive ultrasonic sensor. The resolution isn't that great, but we are going to be smart in the way we use it. And what we're going to do is we're going to put this on the top. And as we rotate the servo, you'll notice if we just put this in a static location, all you get is one reading, that's it. But by rotating the sensor, you have data point, 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 data point. We can get a lot more data out of this one sensor. Now, while we rotate this, it's not going to be the best thing ever. However, these are really inexpensive, and what we've effectively built is a very simple ultrasonic imaging system. But the first thing we got to do is make sure that A, we are correctly detecting the angle between this servo and with this IR sensor. Then we have to make sure this thing rotates no problem. And then lastly, we're going to add this ultrasonic sensor to the top. And then the last step is we're going to have to process this data, which I'm going to put in the next video when we actually move this thing to another board. Because when this thing rotates, the easiest way to do this mathematically is we're going to use polar coordinates. However, if we're going to try to 3D image something, that information for us is a little less easy to read than we use Cartesian coordinates, like X and Y. So we're going to have to use a little bit of code to turn this polar coordinate readings into a distance that we can map into Cartesian coordinates. It sounds really complicated, but it's really not. We can do it on an 8-bit processor. That's not that hard.